Hey guys, welcome to my video on 14-2, solving trig equations. The aim for today is going to be to solve trig equations using inverses. So for the do now, I have a question for you. It states, what is the value of theta for the equation sine theta equals 1/2? So we have to go back to what we remember about the unit circle. Remember, on the unit circle, every coordinate represents the cosine for x and sine of the corresponding angles. So for 30 degrees, or pi over 6 radians, your cosine of this angle is going to be equal to radical 3 over 2, and sine of that angle is equal to 1/2. So if we're looking for all the places on this unit circle for which sine of theta is 1/2, we are looking for all the places where my y value is equal to 1/2. So we take a look. Well, lucky for us, I already have one circled. 30 degrees has y equal to 1/2. So theta is definitely equal to 30. This is also pi over 6 radians. Where else do we have that? Keep going. We see that we have this also at 150 degrees, which corresponds to 5 pi over 6. Okay, we keep going. Well, we see that we have a y equal to 1/2, but it's a negative there. So that would not be a valid degree for this equation. Same thing over here at 330. We see that we have a negative 1/2 in the y. Again, does not have a positive value, so is not a valid solution to this answer. So we see that between the interval of 0 to 2 pi on the unit circle, we have two possible answers. In degrees, that's 30 and 150. In radians, that's pi over 6 and 5 pi over 6. Notice both of these angles have the same reference angle, right? This has a reference angle of 30 degrees. That has a reference angle of 30 degrees. As well as the fact that they are both in quadrants where our trig function matches the sine. Okay, so we're going to be using all of these parts to help us solve equations where it may not actually be on the unit circle. Okay, so we do need something to help us solve these, and that's the inverse trig functions. When we don't have a angle measurement that's on the unit circle, or if we don't have the unit circle handy, we can use our inverse trig function. Okay, the inverse trig function is used when we are given our trig value and need to determine our angle. Okay, so in the last question, sine was equal to 1/2. We have the trig value. We're looking for the measurement of theta. A lot in the past, they used to use arcsine, arccosine, arctangent. I don't see too much of that. I tend to use this notation over here on our right side. Sine with the little -1 of x, cosine with the little -1, tan with the little -1. Now, the issue with this notation is this. Remember how in the last video I told you if you put the square in between the x, it's the same as the whole thing squared? Well, that is not the case here, okay? Sine -1 on the inside is not equal to sine of x raised to the -1 power, okay? Because raised to the -1 power, remember, means 1 over. And that's our reciprocal trig function, okay? So raised to the -1 power actually is cosecant, okay? But this notation on the left-hand side is our inverse notation. We've used this notation before when we talked about inverses in the past. Okay, so as long as you know that those two things are not the same, okay, we're going to be sticking with this notation in our solving processes. Okay, so let's use this. Okay, solve each equation for theta with where theta is in between 0 and 2 pi, including the 0. Okay, so since we're solving, we're still going to use the same techniques we would use in a regular solving equation. Okay, we want to isolate our variable. Now, our variable in this case is theta, and it is trapped inside the trig function. So to get to it, we have to remove, right, anything that is not a part of the trig function. So just like we would always add anything, add or subtract whatever those constants are, and move them to the other side, I'm still doing that. Just like we would divide out this 2, we're still going to do that. Okay? And now we're left with cosine of theta is equal to radical 3 over 2. Okay? If we want to find out what theta is, we are going to need to use the inverse cosine on our calculators and type that in. So to find the inverse trig function, take a look at your calculator. Remember the sine, cosine, and tangent buttons, okay? On top of it, in the second key color, so in my calculator, it's light blue, you'll see sine with a -1, cosine with a -1, and tangent with a -1 over their corresponding buttons. That is the button that you are going to use when you plug this into your calculator. So to type this in, I would press second cosine, and it should pop up. And then I would type in radical 3 divided by 2, close parentheses. Okay? Now, one thing you need to keep in mind here. When we do this, we want to keep it in degree mode. Okay? Now, it's not that it won't give you an answer in radian mode. However, something we know about radians is that typically they are written in terms of pi. And your calculator does not have that capability. So we will typically do this in degrees, because if it works out to a nice clean angle, which in this case it does, we can then convert that, right, to its corresponding radian, pi over 6. Okay, we would not be able to do that if we left the calculator in radian mode. Because if I switch my calculator back to radian mode and type in the same exact thing, I get 0.5235 ... Okay, which is not the exact value. Okay, so we will continue working with this in degree mode, and if it works out to a nice value, we'll convert it to radians. Okay, so that's part of the question. So we see that we have 30. Now, if we remember in the last question, we need to make sure we include everywhere from 0 to 2 pi where the cosine is a positive radical 3 over 2. Okay, so we are looking for degrees with reference angles of 30. Okay, and we're looking for where cosine is positive, right? We're looking for positive. So if we go back, all students take calc. If cosine is positive, we are in quadrant 1. Well, that's my 30-degree angle. And if cosine's positive, we're also in quadrant 4. So what is the angle in this quadrant that has a 30-degree reference angle? Well, that is the angle that goes all the way around here. So how do we find that value? Well, we know that a full rotation is 360, and we subtract our reference angle of 30, and we get 330 degrees, okay? So the other angle that works is 330 degrees, okay? To convert that into radians, we would get 11 pi over 6. Now, you will typically see the answers in radian, okay? The answer key for the textbook is in radian, okay? So although we're working with degrees because the calculator works better that way, we will convert all of our answers to radian measure. Okay, let's try another. Solve each equation for theta, where theta is in between 0 and 2 pi, not including 2 pi. Okay, so now we see we have 3 tangent of theta minus 1 equal to tangent of theta. Now, tangent of theta is considered a like term with itself. Okay, so what I'm going to do in this question is I'm going to move, I'm going to move this 3 tangent theta to the other side. Okay, and because they are like terms, I would combine them just like a like term. So this is technically 1 tangent minus 3 tangent leaves me with minus 2 tangent of theta. Okay. Now we have one trig function, and we're going to isolate that trig function by dividing by a negative 2. Okay, so 1/2 is equal to tangent of theta. Great. So how do we get our theta alone? Well, we use our inverse trig function. So tangent with the negative 1 of 1/2. And when we plug that into our calculator, we get an unfortunate decimal. Okay, we get, let's see, something that rounds to 27. So arc tangent mode is in degree. Okay. Second tangent, type in 1/2, and we get 26.565. So what we're going to do for these when we're in degree mode is we're going to round to the nearest degree. So that's going to be sufficient here. So what is our other angle measurement here? Well, we want a value where tangent is positive. So all students take calc. We are in quadrant 1, which is the 27 degree, and quadrant 3, okay, which is an angle here that has 27 as its reference angle. So how do we find that? Well, we know that it has to go all the way through 180 plus the additional 27, leaving us with 207. Okay, so those are my two angles rounded to the nearest degree. How do I represent this angle in radians? Well, you could do one of two things. You could take these answers and convert them to an approximate radian in terms of pi. That's fine. Okay, but we can also use our calculator to get a little bit more precise by changing the mode back to radians. Okay, so if I type this exact same thing in radians, I get theta is equal to 0.46, and we're going to round 4. Okay, now because these are not exact values for degrees, it's okay that our radians are not in exact terms of pi, because it doesn't work out that way. Now the question is, how do we find the other one that corresponds to 207? Well, remember, we added 180 plus 27 equal to 207 to get that answer. So here we're going to add the radian equivalent of 180, which is pi, plus the radian equivalent of this 27 degrees, which is 0.04, and I would use whatever's in your calculator. And when I add them together, pi plus my second answer, I get 3.605. Okay, and if you did the conversions and typed in the pi, you should get that these are approximately equal to each other. Okay, so that's how we handle answers that don't work out to perfect angle measurements in degrees. Okay, so pause the video and give this one a try. When you're done, unpause it and test your skills. Okay, so we want to isolate our trig value, so that's sine. To do that, I must divide by 2. So we get sine of theta is equal to 3/2. So to type this in my calculator, I need to use the inverse sine function of 3/2. So when I type that into my calculator, something happens. Okay, you might be saying, what's wrong? Did I type it in wrong? Maybe you try radians. Maybe you try degrees. Well, unfortunately, there is no solution. Okay, this is going to give you a big error on your calculator. Okay, which means that there is no solution. Okay, there are no values of theta that satisfy this trig function. Now, let's think for a second why that could be. Well, remember, sine is equal to opposite over hypotenuse. Well, if that is equal to 3/2, that means my opposite side has to be greater than my hypotenuse. And that is impossible. Okay, because the hypotenuse is the longest side of a right triangle. So if you ever see a fraction where the numerator is bigger than the denominator, okay, we have a little bit of an issue. Okay. Let's try, I think we have 2 more left. Okay. Why is this one different? Why are we trying this one? Well, now we've moved away from the basic 3 trig functions, the primary, sine, cosine, and tangent, and we're moving into our reciprocal trig functions. Okay, so let's think back to 14-1. What did we do when we had non-primary trig functions? We converted them. That's exactly the same thing we're going to do here because we do not have a secant button on our calculator, nor do we have the inverse secant button on our calculator. So we need to write it in terms of one of the buttons that we have on our calculator. So secant is related to cosine, right? It's 1 over cosine of theta equal to 2. So now, however you want to solve this, you can solve this using a proportion, you can and cross multiply, you can understand reciprocals and just flip them, but when we do that, we get that cosine of theta ends up being 1 over 2. Okay, so to get our answer, theta is equal to the inverse trig function of cosine of 1/2. Okay, make sure your calculator is in degree. And we get that theta is equal to 60. Okay, so now where is our angle going to be? Well, 60 is positive. All students take calc. Where is cosine positive? In this, quadrant 1. Reference angle of 60 is 60. Great. And in this quadrant, what angle in quadrant 4 has a reference angle of 360? Well, we take the big full rotation, subtract 60 from it, and we get 300 degrees. Okay, since these are both exact values, right, we did not have to round, we can do a direct conversion. And in radians, this is equal to pi over 3, and 300 is equal to 5 pi over 3. Okay, so those are our final answers. All right. And now for the last and final challenge question. Solve each equation for theta. Okay, so we have sine of theta is equal to negative sine theta times cosine theta. So you might be thinking, oh, well, when we had 2 tangents, right, I could just add them together. So why don't we do that? Well, let's move sine of theta over to the other side. But wait, sine of theta is attached to cosine of theta. So these are no longer like terms. Okay, so I end up having to rewrite it as sine of theta plus sine of theta cosine of theta. Okay, so you might be saying to yourself, what do I do? I'm stuck. Okay, well, we have one tool at our advantage, and you're going to use this anytime you feel like you're stuck with one of these pluses or minuses and our trig function separated. And that is factoring. Okay, we can take out a greatest common factor of a trig function to make things a little bit easier for us. So what do I mean? Well, sine plus sine cosine has a common factor of sine of theta. So if I pull that out as a GCF, okay, that leaves me with the 1 as the first term and cosine of theta as the second term. So now we have sine times this parentheses. Notice it's equal to 0. So do you remember what we did last time when we had quadratics or polynomials and we factored equal to 0? We said each of the factors equal to 0. That's exactly what we're going to do here. Sine of theta equal to 0 and 1 plus cosine of theta equal to 0. Each can be solved separately. Okay, so to type this in our calculator, how do we do it? Well, theta is equal to the inverse of sine of 0. When you type that into your calculator, it gives you the answer of 0. Okay, now the only other angle between 0 and 2 pi that's also equal to 0 is 2 pi. But notice, it is not including 2 pi. It's strictly less than, so we only need 0. And now, great news, 0 degrees, 0 radians, same thing. Okay, so now how do we solve this one? I'm going to isolate my trig function and use my inverse trig function. Cosine -1 is equal to -1. What do we get on our calculator? Great. This theta is equal to 180 degrees. Okay, well, 180 degrees only has, there's only one angle that has 180 degrees as its reference angle. Okay, so we don't have another one of these. So what's left? Well, I need to convert this to radians. So theta is equal to pi. So my answers